Hello, let me help you in making your mathematics strong. Now children, if you remember, in the last turn we discussed about a geometric progression. We talked about the basic characteristic of a geometric progression, that if you divide two consecutive terms, the later term by the earlier term, we get the common ratio. Now this can be T20 divided by T19, or it can be T200 divided by T199. So both of these should be the consecutive terms, and you divide the later term by the earlier term to be able to get to the common ratio, right? So after we get the common ratio, then we also have to find out the nth term of a geometric progression, and that, children, is given by Tn is equal to a times of r raised to the power n minus 1, and as it is also said to be the last term, that's why we write it with a small l. Now children, as these are two important formulae, so I will put them in a box. So let's say now this is the first formula, right, which is very essential for you, especially for this sum. And now the other formula also, I will put it in another box. So let's say now this is the box which helps you in tracing that this is something which is important, and as such you will be able to learn this, and in times to come when you do your revision, then too it is going to help you, right? So this is the second formula. Now children, after this we now have this sum which we discussed in the last turn. I'm sure you people remember that we talked about the p plus qth term of a geometric progression to be m, and we talked about the p minus qth term of the geometric progression to be small n, and with that we got these two equations, as we know that Tn is equal to a times of r raised to the power n minus 1, and then we divided both the equations and we removed this variable a, which is the first term, and the second variable r, its value was calculated to be m upon n whole raised to the power 1 upon 2q. Now I'm not repeating this because I think that you people must have revised all of this and must have done this sum once all on your own. If you haven't, I request you to get back and try out the sum all on your own once. If you stumble somewhere, look at the solution, but then you require to do this once more, which I normally call CWDA, that is class work done again. And do remember, this is something which is very important in you to be able to learn mathematics, and this is time tested and it is tested on many students. Everybody appreciates this, and they tell that this really augments your study of mathematics like nothing else. Okay, so after you have done a practice of this, then I'm sure you would have understood how we've got this common ratio. And now to be able to find out the first term, what we did was we've kept this value of r in any one of the two equations that we have, that is either Tp plus q or Tp minus q. We've kept it in the first equation, and then we made r the subject of the equation, a the subject of the equation, as r has already been found out, and then we get to a value of a which is not so pleasing, but this is what it is. Now after that we have put up this value of a and that of r to find out the pth term, and then we've proved it to be actually root mn, right? So this was that process. Now children, we have to look up the second part, in which we're going to talk about now the qth term, and it has to be m times of n upon m raised to the power 2 p upon 2q. So this is what we'll write now. That is, we have to now prove, that is, we can say to prove that we have the tqth term, right, and that is equal to, obviously it should be a into r raised to the power q minus 1, but here we've got to, in times to come, prove it to be equal to, first we have m, and then we have n upon m, which is whole raised to the power p upon 2q, and this is what I will quickly check. So we now have to prove that we have our qth term to be m times of n upon m raised to the power p upon 2q. Okay, so this is the qth term, right? Yeah, this is the qth term. Okay, so now we get ahead and we try to prove this. So for that, first we start off with the basic formula that we know, that if we talk about some Tn, right, then that is given by the first term multiplied by the common ratio and raised to the power n minus 1, that is one less than the number of terms. Now children, this obviously is also going to be applied to the qth term. So as such, in accordance with the formula, we will now have tq, that is the qth term, to be equal to a, which is the first term, multiplied by the common ratio, which is small r, and it will be raised to the power q minus 1. But children, we have the value of a that we are going to substitute. Now what is the value of a? The value of a, or the first term, is m raised to the power q minus p plus 1. M raised to the power q minus p plus 1, and all of this is divided by 2q. And now then we have the power of n, and the power of n is how much? It is p plus q minus 1. So p plus q minus 1, and all of this is divided by 2q. So this is the value of just a, right? Now after this we will also be talking about r, and if you remember, r was pretty simple. It was m upon n, which was raised to the power 1 upon 2q, although I will quickly go and check it out what this is. So if you talk about the value of r, it is m upon n raised to the power 1 upon 2q, and as we have here the power of this to be n minus 1, so the whole power, children, is going to be n minus 1. I'm sorry, not n minus 1, but q minus 1, right? So here the whole power is going to be q minus 1. Now children, here what we're going to do is, as there are certain terms which are with m and certain other terms which are with n, and we know this rule that if you talk about some a raised to the power m which is multiplied with some a raised to the power n, then that becomes equal to a raised to the power m plus n. And similarly, we have another rule which tells us this, that if we have some a raised to the power m which is divided by a raised to the power n, then that, children, becomes equal to a raised to the power m minus n. So both of these rules are going to be used, and as such then we'll be able to get to the powers of m and n, and it should correlate with what has been given to us to be proved, and that we'll check in times to come. So next now, children, we will further solve this out. As such, tq that we are planning to find out is now going to be this value of m, right? That is m, which is raised to the power q minus p plus 1 divided by 2q, and except that you also get to see that there is another m, and its power will become 1 upon 2q, which will be multiplied with q minus 1 again, because if we talk about, say, some a which is raised to the power m, and if it is whole raised to the power n, then that becomes equal to a raised to the power m into n. So using this power rule of indices, we will now have the product of 1 upon 2q and q minus 1, and as such it will become q minus 1 upon 2q, right? So we have now the power of m, which also is how much? Q minus 1 upon 2q. Now children, after this, next we talk about the powers of n, and one of the powers of n that we have is the first one, that is p plus q minus 1. So we have p plus q minus 1. Remember, the denominator is 2q, which all through is common, and as such it is going to provide us a lot of benefit. Now if you talk about this power of n, it is in the denominator, and it is q minus 1 upon 2q. So we will write it in the denominator. That is, this is n, which is raised to the power q minus 1 divided by 2q. Right now, children, here we will be using these two rules that we just looked up. One, when we have the product of two numbers which are in the exponential form, their bases are the same, then keeping the base to be the same, we just add the exponents or we add the powers. So as such, we'll be adding up the powers of m in both of these numbers. So doing that now, in the next step, we will now have here m, which is going to be raised to the power q minus 1, q minus p plus 1 plus q minus 1, right? That is because the denominators of both of these fractions is exactly the same, that is 2q. As such, the LCM will be 2q and the numerators will be written as it is. Now here, children, we get to see that there are certain terms which will get cancelled, like we'll have minus p, which is now not going to get cancelled, right? And we find that we have minus 1 plus 1, which will get cancelled, right? And except that this p is going to remain, and we will have 2q here, right? So in the next step, then we will write it down, and now we'll be talking about finding out the powers of n. Now, in order to find out the powers of n, children, we get to see here that here we have one n raised to some power in the numerator, and we have another n raised to some power in the denominator. As such, if we talk about now writing the power of n, it will be from the power of the numerator, we'll be subtracting the power of the denominator, as the quotient rule of indices tells us. So now next, we will be having p plus q minus 1, right? And from that is to be subtracted q minus 1, right? And this can be done because the denominator of both of these fractions is 2q. As such, the LCM will remain to be the same, and we just have to write what the fractions numerators are. Now here, children, we get to see that there are certain things which are getting cancelled, and now we cancel them. So here, children, we get to see that we have minus 1 and minus minus plus 1. So both of these ones, they get cancelled, right? I said it is minus 1, and then you have minus minus, that is plus 1. So plus 1 minus 1 gets cancelled. Next, if you talk about q, here q also gets cancelled because we have plus q and minus q, they will get cancelled. So only p will remain here, right? So as such, now, children, in the next step, now we can write the simplified expression. So we further now have m, which is raised to the power q, rather 2q, because q plus q will become equal to 2q, and then we also have minus p, right? And it is whole divided by 2q, that too we are going to write. Now further, if we talk about the power of n, then the power of n is p, and except that we have nothing else because everything has got cancelled. So this will be p upon 2q, which will be the power of n. Now, children, we will try and write it in the form as was given in the question to prove. So for that, what we can do is just remember one thing, that if say we have something like a, right, to which say another number b is added, and that is divided by c, so obviously we can write it to be a, to which we have the denominator to be c, and now to it can be added b, which is again divided by this number c in the denominator, because when you take an LCM, the old fraction a plus b upon c will come back. So this is what we are going to do in the first power. So now we have m, which is raised to the power 2q divided by 2q, where both of the two q's will get cancelled from the numerator and from the denominator, and we have minus p upon 2q, which is another term in the power of m. Now in the power of n, we have p upon 2q, right? Now, children, what we do is we are simply to cancel this 2q and this 2q, and indeed what will happen is we will now get m raised to the power 1, which is one of the powers, and the other will be m raised to the power p upon 2q, but in the denominator, as the power is negative, right? And as such, what will happen is it will go over to the denominator. I will increase one more step so that you can have a better understanding. So in the next step now, children, we can write this as m, which is raised to the power 1, right? And we have the other thing, which is m raised to the power minus p upon 2q. Did you understand this? Because here, if there is a sum of two numbers, we can write that as a product of two exponential forms where the base is the same and one of the powers is 1 and the other power is minus p upon 2q. Now the next number is n, which is raised to the power p upon 2q, right? And further then, children, we can write this now as some m, right? And then further, as the other power of m is negative, so we're going to write it like this. Like if we talk about a raised to the power minus m, then children, it can be written as 1 upon a raised to the power m. So this is how we are going to simplify this. That is, we'll have m raised to the power m, or just m, and we'll have 1 upon m, which is going to be raised to the power p upon 2q, and except that we also have n, which is raised to the power p upon 2q. So now in the next step, we can obviously write this as m, which is multiplied with n, right, which is raised to the power p upon 2q, right, and divided by m, which is again raised to the power p upon 2q, right? I'll rather write this in a better way so that you can understand this better. This has become a little jumbled up. So this is m raised to the power p, which is divided by 2q, right? Now this is the power, but this has gone a little too low, right? But just be with me and just try and understand that this is actually because we are handling numbers which are fractions, that too in the power, and we've got to write big too so that you can see. So you just have to manage it, okay? Now in the next step, children, we can write this as again m, right, which is to be written separately, and further except that we now have n upon m, whose whole power is p upon 2q. So obviously this is going to accord that we have n, which is raised to the power p upon 2q, and m, which is raised to the power p upon 2q. As such, it can be written like this, and if you try and match with what we had to bring, right, it matches exactly now. So we had to bring this, that we have m times of n upon m, whole raised to the power p upon 2q, and we've been able to achieve it. Okay, so now children, I will be quickly explaining this all over to you people, and if there is any doubt withstanding anywhere, do tell and I will repeat it for you, right? Okay, moreover, I will try my best so that you don't have any doubt. Okay, so now children, we are looking up the second part of this, and we are considering that we have already found out the value of a and r as they are the variables. Now we have to talk about the qth term, and it has to be proved to be m times of n upon m raised to the power p upon 2q. So what we do is we first apply this formula, Tn is equal to a times of r raised to the power n minus 1, and in tq we substitute this. So we will have a, which is multiplied with r whole raised to the power q minus 1, right? Now we substitute the value of a from above, right? So we have the value of a, which is what? This very big and tidy. So now we write this value of a, and after that we have r, which is raised to the power n minus 1. So the value of r also has to be substituted, and this is the value of r, which now we will substitute in place of r, right? And it is whole raised to the power q minus 1. That is what we will write, right? So in the next step, children, what will happen is we will have these three rules which will be applicable some way or the other. The first is a raised to the power m multiplied with a raised to the power n will become equal to a raised to the power m plus n. This is known as the product rule of exponents. Then if we have a raised to the power m, which is whole raised to the power n, then that becomes a raised to the power m into n. This, children, is the exponent or the power rule of exponents. Okay, now if we talk about a raised to the power m, which is divided by a raised to the power n, it becomes equal to a raised to the power m minus n, and this is known as the quotient rule of exponents. So here further we require first to multiply the first rule, where we have the power of m to be 1, which is q minus p plus 1 upon 2q, and the other which is going to become q minus 1 upon 2q following this power rule. So first we write it, and then in the next step we also add this up, as the denominator is exactly the same, so that becomes the LCM, and we just add up the numerators. Now after that, children, we talk about the power of n, which is a little difficult to solve because one power is in the numerator, which is p plus q minus 1 upon 2q, and the other power is in the denominator. After application of the power rule of exponents, it will become n raised to the power q minus 1 upon 2q. Right, so now we keep one power in the numerator and the other power in the denominator. Now as we have this rule, which is the quotient rule, so now this power is going to be subtracted from this power. That is what we do, and it becomes simple because both of these again have the same denominator to be 2q, and as such you just have to write the numerators, and from the numerator of the first fraction you got to subtract the numerator of the second fraction. Now children, after this we get to see that there are certain terms which get cancelled in the power of m as well as in the power of n. In the power of m we have plus 1 minus 1 which gets cancelled, and in the power of n we have a lot which gets cancelled, like q and minus q when minus is multiplied within, and then further when minus is multiplied within to minus 1, it will become plus 1 which gets cancelled with minus 1. So we are just left out with n, which is raised to the power p upon 2q. Now when we talk about the power of m, it is q plus q, which is 2q, from which p is subtracted and it is divided by 2q. Next, now children, what we do is, if we have some a plus b which is divided by c, then that becomes equal to a upon c plus b upon c, right? Because if we take the LCM, we will have the old fraction back. As such, what we do is we also here do the same, that is we write the power of m now as separated to be 2q upon 2q and minus p upon 2q. So obviously 2q gets cancelled and you get 1, right, which can just be written as m, and the other power of m is minus p upon 2q. Now if you note, the power of n also is p upon 2q, but the one which is of m is negative, as such it will go to the denominator. So now you have n raised to the power p upon 2q divided by m raised to the power p upon 2q, and this is how we can write this. And further then we can write n upon m in a single bracket, and the whole bar can be written to be p upon 2q. So when the power rule will apply, the power of n as well as m will become p upon 2q. Now children, if we try and match as to what we had to bring, that is, we had to prove that tq is m times of n upon m raised to the power p upon 2q, and children, this is what we've got, and as such we can say that we've been able to prove the sum. Therefore we can say that therefore proved, and it is so much peace giving at the end of a proving sum if you've been able to write proved. So has everybody been able to understand this? Sure. Umar, and then Huzaifa, and then Agnihotri. Everybody clear? Hamid? That's good. Okay children, so for you people, I just devised this because I thought that if this is before you, you'll be able to understand this better. But I expect one thing from you. Will you do it for me? Yeah, please do it. That is, you will now have to do the sum all over, all on your own, so that if it comes in examination, you're able to do it with ease. Right? Remember children, there are 4 P's. The first P is presence. That means you have to be here and you have to look up the sums or the lectures, right? Number 2 is position. That means you have to be sitting straight on a table and chair. You have to focus exactly where the teacher is, and you got to ensure that you're sitting at a place where there's no disturbance. Number 3 is procuring. So you procure the knowledge which I'm giving you, obviously by training your brain that this is the time when I have to get this, and then I have to also do it. As such, I have to study this astutely with all my presence of mind, with all my attention. Number 4 is practice. When you practice all of these once more, right, all on your own, then that is CWDA, that is classwork done again, and that ensures that you've been able to understand this very well, and when it comes or some similar to it comes, then you'll be able to solve it with ease. So make sure you do all of this before and get yourself understanding mathematics in a very easy way and become a specialist in it. So let me make your mathematics strong, and let we all have strong mathematics, as my mission is to make 1 million teachers of mathematics who will be teaching our society to be really good in mathematics. Bye children, have a nice time. Bye.